For the last session today, we're going to be hearing from Margaret Gatz and Stefan Schneider together, and they're going to be discussing the design of a perceptual speed test for the Understanding America study, which now is very familiar to all of us here. I think Margie is going to begin with it for us. Margie is a professor here at the University of Southern California. Margaret, would you like to take it away?
Yeah, thank you. So I'm going to describe adding a perceptual speed test to the cognitive measures that we already had as part of the Understanding America study. And Stefan and I are speaking for the entire UAS cognition team. Next. So in the array of cognitive skills, processing speed refers to how long you take to take in information, understand it, and begin to act on it. Some people do this faster than others. Notably, processing speed is not the same thing as other cognitive skills, such as attention. It's not intelligence. They don't necessarily predict one another. Processing speed is something that you can improve with practice. It slows with age, so that in older adults, there are declines in processing speed, and these may indeed portend other cognitive changes. Next. As processing speed slows, this inevitably affects the ability to do other things, such as complex decision-making. And intra-individual variability in processing speed is an important marker of things like fatigue, or this may be noticed following a concussion or as part of some other neurologic disease. Generally, processing speed is measured as time to perceive and respond to visual information, hence the term perceptual speed. So we wanted to add this cognitive ability to the UAS survey. There's a lot of paper and pencil measures. Digit symbol substitution task is a commonly used paper and pencil measure, or a scan task where you cross out a symbol every time it appears in a large collection of other symbols. But the challenge of picking a task that would adapt well to online administration led us to choose figure identification. This is a task with a long history of use with kids, use in longitudinal studies of aging, and adaptable for online. The version we chose has been used in the Durman-Selda battery, which is part of Swedish studies of aging, but it stems back to Thurstone, and there's many similar tasks available historically. So our job we assigned ourselves was to program it for UAS, which required making it available for both keyboard and touchpad. And this is the task. You are shown a target figure and a series of figures, and you are asked for each of these sets as quickly as possible while still being accurate to pick the one that matches.
Okay. Stefan. I'll take over. Thank you, Margie. So let me just spend a few minutes telling you a little bit about the analysis that we're currently conducting to evaluate the implementation and the performance of this figure ID task in the UAS. Major goals here are, as Margie said, to compare keyboard versus touchpad. That's really important because in the UAS, folks are free to use whatever device they currently have available. So in order to really be able to track changes in cognitive functioning over time, we have to ensure that the performance between these platforms is comparable. And another major goal is to create norms and parallel short forms of the figure ID test in the UAS. So we conducted a within subject randomized experiment where we invited participants to complete all of the 60 items that we have available from the paper and pencil version, once using a regular computer with a keyboard or a laptop with a keyboard, and ones with a smartphone or a tablet in randomized, within subject randomized order. And here is some of our current, why can I not move it? Some of our current results are on the next slide here. So one basic question whenever it comes to speeded tasks is, can we focus on response times, or do we need to also take incorrect responses into account? And this is what this figure tries to illustrate a little. You see the proportion of correct responses, or proportion of people who got the figure correct across all of the 60 figures. Comfortingly, maybe you see that for most figures, 90% or more of the individuals got them correct. So after we eliminate some of those bad apples that are on the left-hand side of the line, we think that we can simply exclusively focus on response time. So that simplifies the scoring quite a bit. So focusing on response times, major question, as I said, is do the response times differ by platform? And this is a simple histogram showing the distribution of differences in response speed between keyboard and touchscreen, where you see that on average, there is absolutely no difference whatsoever, which was striking and something we don't find with other speeded tests, where we do see platform differences, but there's absolutely right now no average platform difference. There are individual differences though. Some folks are faster using a keyboard, others are faster using a smartphone, and I'll get back to that in a second. Next basic question is, we were hoping and expecting that this will be an age-sensitive cognitive test, and here you just see a scatter plot of the correlation between the average response time and age, and you see a very pronounced correlation of 0.55, so it is very age sensitive, and we're very happy about that. So going back to this question about individuals, some folks are faster using a keyboard, some are faster using a smartphone, obviously. Then you start wondering, well, maybe the older people are slower using a smartphone because they're not so used to it, and younger folks maybe especially fast on a smartphone because they're using it a lot. So is there a correlation between the platform difference and age? And this is what we look at here. Here the y-axis is actually again showing the individual, for each individual, the difference between keyboard and smartphone or touchpad. And you see absolutely no relationship between age and the platform difference. Again, very comforting. So I'm showing lots of comforting results here that we were positively surprised to see. So what we're currently doing is we're working on the norming part and the short form creation. And one of the basic questions here is, how many figures do we need to get at a sufficiently reliable score, right? And this graph just shows the internal consistency reliability as you add on more figures. And as you would expect, the reliability goes up for more figures, but 20 figures or so are obviously enough to obtain a reliability that's really high, above 0.95. That said, here's the last slide showing some of the current challenges that we're dealing with, but also opportunities when it comes to norming of the test. So this is a little bit of a more complicated slide showing, just recall that individuals were completing all 60 items twice in a row, right? For, using a keyboard and using a touch screen. And so this figure shows the average response times for all of these 120 items. And first off, you see that there is, again, relatively little difference between keyboard and touch screen, but there are some very pronounced dynamics that we're struggling with a little bit, or looking at least. One is that there is a noticeable fatigue effect over the course of 60 items. People get slower as they complete these 60 items, but even more strikingly, there is a training effect. As people do the test again, they get a whole lot faster. So this creates some real challenges when it comes to norming, because now we need to find ways to translate this dynamic onto the expected response time that you would find had people only completed 20 items, which there are multiple ways of thinking about that. But there are also really maybe cool opportunities here in that a fatigue effect and a training effect. There may be individual differences in that. And these may be really important markers of cognitive functioning and cognitive aging in and of themselves. So we may not want to throw out those important signals and maybe get multiple test scores from this test rather than just having an average response time processing speed indicator from that. That's it. Thank you. Joanne, you're muted.
Oh, in fact, thank you very much, Stefan, whom I didn't actually manage to introduce at the beginning. Stefan is a senior behavioral scientist here, also at CIPHER. Can I open the floor for questions, please? This is the last session, so if you have been dying to ask a question in this session, now is the time. In the meantime, if not, I'll take the prerogative to also ask a question. I have to say, Stefan, some of it was not very comforting because I was not able to answer your task in the time that it took you to change the thing. But I realized that because it's my birthday on Monday, probably that's an aging effect. So perhaps, and maybe if I try a little bit more, I will be, if you try it with me tomorrow, probably I will be trained and much more quickly. But I wanted to ask you, maybe you mentioned in passing that that there was zero platform effect, which you didn't anticipate because in other sort of tests of this kind, that's not commonly found. Could you say something a little bit more about this?
Yeah, we are also looking at the BTACT, which is a little bit of a more complex cognitive task where there's a lot of task switching involved. And for that one, we saw that the keyboard was a whole lot faster than the smartphone for reasons that we couldn't really explain. In part, maybe that's all driven by implementation, how well you implement the test and how standardized you are, the level of standardization that you apply can matter a lot. So some of these platform differences that we saw for the other test were due to, we think, having a little bit of a crowded screen, having next buttons that were unnecessary and distracting, then more distracting on the smartphone than on if you have a larger screen, and really telling people exactly where to put fingers and which hand to use and where to look. Yeah, really trying to standardize takes some of those platform differences away. So where you think, oh, this is a real platform difference, may turn out just to be an artificial difference that's based on suboptimal implementation. But yeah, so there was comfort. Maybe this test is so simple that those effects fade away.
And I think one of the themes that we are hearing in this panel is that simple is better. I do want to sort of turn the last question to Hema Zamaro, who says that in her work, she's found measures of rapid responding in general as a measure or maybe a negative measure of diligence or conscientiousness. So I was slow because I am a very diligent person. I've asked, have you thought about linking some of those messages or measures to your task? So measures of diligence or conscientiousness as well. Is that something that you've thought about?
Well, that's, yeah, it's part of a long-term grant that we're working on where we are linking self-report response times and self-report indicators of carelessness and of diligence to those cognitive tasks. I mean, we have so many multiple sources in the US. We can look at the diligence in the self-report measures. There's also potential lack of diligence in these cognitive tasks, which we don't think we see a lot when you look at the very first slide that I showed, that very few items were, well, maybe it's because I just said, well, there are a few items that that not almost everyone got correct, but even there, yes, there may be people who are not diligent and they're driving this lack of 100% accuracy. So it's an interesting idea that you also want to think about lack of diligence in that cognitive test here for a subset of individuals. We haven't looked at that.
Yeah, I think also that this is deliberately designed to be simple enough that diligence may be better captured by some of the other tasks that Stefan refers to, and that this hopefully more directly is really capturing speed.
Yeah, well, I think that's a lovely note actually to end this panel on, and to say that, right, with the theme about simplicity and clarity and designing specifically for this environment, but also with a reference to the richness of how we can explore some of these hypotheses with data like the Understanding America study. And that gives us so much more room to explore some of these that we normally wouldn't be able to do in a single setting with a limited amount of variables as well. And I think to get these number of questions from researchers, I think, oh, well, literally from all kinds of different settings with the same form of data is such a great feature of the Understanding America study. Thank you guys, everyone, for this panel. I think we are directly bang on time. So I'm going to end it here. Thank you, everyone, for your participation. I'm going to hand this back over to Tara and to Ari as well.